exercise 2 to sum number 83. The force acting upon a charged particle kept between the plates of a charged capacitor is F. If one of the plates is removed, here two plates are kept like this. Between them, here charge Q is kept. So here force on this is given as F. Here electric field between the plates E is equal to sigma by epsilon naught. Sigma by epsilon naught. Therefore, F is equal to here QE, which is equal to Q in Q sigma by epsilon naught. That is the force. If only one plate is there here, Q, then force is acting F dash, let us say. Here, electric field due to only single plate is equal to, we know that, sigma by 2 epsilon. Second plate, another sigma by 2 epsilon. Sum is equal to sigma by epsilon naught here if two plates are present. Only one plate is present, then field is this one. Therefore, force acting on the charged particle F dash is equal to QE, which is this is E dash, QE dash. So Q sigma by 2 epsilon. But Q sigma by epsilon naught is equal to F. So here instead of this, we put F. So answer is F. Right? Is it clear?
Yes, sir.
Okay. This is from exercise 2. Next, exercise 3 నుంచి పేజ్ నంబర్ 161 లో ఉన్నాయండి. 161. Problem number 66. A parallel plate capacitor has an electric field of 10 power 5 volt per meter between the plates. If the charge on the capacitor plates is 1 microcoulomb, the force on each capacitor is each capacitor plate. Here, what is the formula for force? F is equal to half epsilon naught E square M. That is the formula for force. But E is equal to here Q given, E given. So one should eliminate epsilon naught and M. How can you eliminate it? But we know that E is equal to sigma by epsilon naught. Sigma is nothing but charge per unit surface area. Distance wise, epsilon naught A is equal to Q by E. So substituting here, therefore we get F is equal to half into, instead of epsilon naught A, we write Q by E. Q by E into E square. So here, this square, this gets cancelled with each other. Half Q E is the formula for force now. Here, substitute the values. Half into, what is the value of Q given? 1 microcoulomb. 1 into 10 power minus 6. What is the value of field? Electric field given E is equal to 10 power 5. So which is equal to 0.5 into 10 power minus 1.
0.05.
Right, correct. So answer is 0.05 Newton. SI unit of force is Newton. That's the answer. Ma, all of you completed?
Yes, sir.
Yes, sir. 1 minute, sir.
Oh, not all.
Done, sir.
Okay. Next 67. Here, a parallel plate capacitor is connected across a battery of potential EM. Then this is what this plate is connected to a spring. This is the spring like this. Whose spring constant is equal to K, let us say. Okay, area of both the plates is A. Area of each plate is A given. And the separation between them is D given. When capacitor is uncharged. When capacitor is uncharged, it means like this. This is uncharged like this. Then distance between the plates is equal to D. When it is charged and a spring is connected like that, then what happened? Due to the force of attraction between the plates, the distance between them decreases. That means this is fixed, but this is movable. Why? Because it is connected to spring. So it moves towards the plate, and hence this spring elongates. So that is the concept here. The steady state separation between the plates is 0.8. So this distance is between this now 0.8. Actually, here 0.8. That means the spring is elongates by x is equal to d minus 0.8 d, which is equal to 0.2 dm. That is the concept. So here, the force of attraction acting on the plate is equal to the elastic force. F is equal to kx. Spring first year lo vastund kada. In SHM, we get that formula F is equal to kx. Okay, equating them, we get the answer. Simple. Draw this diagram. Here we want to find out this K value. Find the force constant of the spring. That means spring constant of the spring. If the force acting on this is equal, let us say F. In equilibrium, F is equal to Kx. This F is nothing but Q square by
2 epsilon naught.
2 epsilon naught A. No, formula for force.
Yes, sir.
Yesterday I gave formula. Charge on the plates is constant, in equilibrium is constant. That's why Q square by 2 epsilon naught D is the force, which is equal to K into X is 0.2 D. But here Q is equal to CE. No, here E is potential, not electric field. So Q is equal to CE means C square. E square by 2 epsilon naught A is equal to 0.2 means 1 by 5 kd. Since Q is equal to CV, instead of V here given E. Instead of V, Here given EL. That's why we should find out the answer in terms of E, not V. Now here, what is the C value? Capacity of a panel plate capacitor. Emma, capacity of a capacitor, air filled capacitor, formula ఏంటమ్మా? Capacity of a panel plate capacitor. Anyone? My students, be active.
Yes, sir.
Capacity formula ఏంటమ్మా? Air filled capacitor formula. C is equal to, or C naught is equal to epsilon naught A by D కదా? Emma?
Yes, sir.
Epsilon naught A by D. Here there is no dielectric. That's why only epsilon naught. So this C value is equal to epsilon naught A by D. What is the distance between them now plates? 0.8 D whole square into E square by 2 epsilon naught A is equal to 1 by 5 kD. Now simplify it, we get the answer. This implies epsilon naught square A square by this can be written as this number 64 by 100 into D square into E square by 2 epsilon naught A. This here is A cancel, this square, this epsilon naught cancel, which is equal to 1 by 5 kD. This implies here this 100 goes to numerator, 100 by 64 into epsilon naught A by D square into E square by 2 into, when this 5 and D taken this side, this becomes 5 by D is equal to K. Now simplify this, we get the answer. Here 2 50 times cancel. 232 times 25 times cancel. So 25 into 5, 125. Epsilon naught A E square by 32 D square into D cube is equal to K. This is the answer. Fourth option. The concept is clear or not? Any doubt is there?
No, sir.
No doubt, sir.
Okay. Here, due to the force on this plate, due to this plate, when it is charged, is equal to the spring force Kx. Actually, this distance is given D. This distance is given 0.8 D. That means this spring elongates by x is equal to 0.2 D. In equilibrium, this electrostatic force on the plate is equal to spring force on this. So this distance remains same. That's why F is equal to Kx. But if charge on the plates is a constant, then F is equal to Q square by 2 epsilon naught A is equal to K into 0.2. But E is equal to C. Instead of V, we given symbol is E. That's why we use C. That's why C square is square. But we know that C is equal to, if you want to note down, since C is equal to epsilon naught A by 0.8 D. That's why we use this. Instead of C square, we use this whole square into E square by 2 epsilon naught A is equal to 1 by 5 kD. Now simplifying this, we get K is equal to 125 epsilon naught A E square by 32 D cube. Important model. All of you
Yes,
completed? Next sum 75. 75. The electrostatic force between the metal plates of an isolated parallel plate capacitor C having a charge Q and area A is an. So here having charge Q, F is equal to half epsilon naught A E square gadamma. Here it has a charge Q. So we should eliminate this electric field EM, where E is equal to, what is the formula? E is equal to sigma by epsilon naught, which is equal to Q by epsilon naught A. Substituting here, we get F is equal to half epsilon naught A into E square means Q square by epsilon naught square A square. So A cancel, epsilon naught cancel. This simplifies, we get F is equal to Q square by 2 epsilon naught A. So it is independent of distance. Independent of distance between the plates. Therefore, force is independent of distance between the plates. First option correct. Okay, with this problems completed. Problems based on force. Completed.
1 minute.
Yes, sir.
Done, sir.
Now let us discuss about current electricity. New chapter. Note down heading. Current electricity. Here, what is the difference between static electricity and current electricity? Static means rest. That means the study of properties of charges at rest is the electrostatics or electrostatic electricity, in which the properties of charges that produces electric field, electric potential, electric force, these and all are discussed. Here, if charge is in motion through a conductor, then it produces current. So here, this is the current electricity, means it is the study of properties of charges in motion. When a charge is in motion, it produces current. Based on that, this current electricity chapter is developed. Okay, ma. Here, in general, this is a metal. Consider this is a metal conductor. In a metal conductor, there are so many number of free electrons. What is a free electron? Tell me anyone. What is a free electron? Emma, what is a free electron? Chemistry ఉంటుంది కదా. What is a free electron? The valence electrons which are not bound with the nucleus in any atom are known as the free electrons. In metals, there are plenty of free electrons are available in the valence band. They are ready to move. But actually, if there is no external field is applied across the conductor, then these free electrons are moving randomly in all directions, so that the average velocity becomes equal to 0. So here in this, electrons are moving randomly like this. This is electron, this is electron, this is electron, this is electron, like this. Electrons are moving randomly in all directions like this, so that their resultant average velocity is equal to 0. Average resultant velocity is equal to 0, like this. These are the electrons. E minus, E minus, E minus, E minus, like this. E minus, this is E minus, E minus, E minus, and so on like that. So that average velocity of electrons is equal to 0. So they are at rest only. There is no current passing through the conductor. At the same time, if electric potential is applied across this conductor, electric potential, by connecting a battery between the ends of the conductor like this. This is a conductor, in general metal conductor. So it is applied, then all the electrons, electric field is produced in this direction. Electric field E bar produced from positive end to negative end. This is positive, this is negative. Here potential applied is B. Here the length of the conductor is, let us say, L, from here to here. Then current flows from left to right. This is current I flows. So in the conductor, current flows from left to right. But all electrons are drifted in the direction opposite to electric field. Why? Because force on electron charge is equal to minus EQ. Here this positive end attracts the electrons, this negative end repels the negative potential, repels the electrons. That's why all electrons are repelled by this negative polarity and attracted by this positive polarity, and hence all the electrons are turned in the direction opposite to the electric field and travels with a constant velocity known as drift velocity. This is known as drift velocity. Here, drift velocity Vd is in the order of 10 power minus 4 meter per second. Like this. That velocity all are moving in this direction. So current is in this direction. So current also in this direction. Current. So current passing through this wire is from positive end to minus negative end. Here this potential is very high, this potential is low. So current always flows from positive and high potential end to low potential end. So it has a direction. Even though it has a direction, it does not obey the laws of vector addition. Here different currents are added simply by normal addition without using parallelogram law of vector addition. That's why Current is a scalar quantity, even though it has a direction from high potential to low potential. That is important. Is it clear?
Yes, sir.
If there is no external electric field, all are moving in a zigzag manner, and so that the average velocity is equal to 0. So electrons does not move from one end to the other end. If external field is applied across the ends of the conductor, all electrons are turned in the direction opposite to the field, external field, and moves with a constant velocity called drift velocity, denoted by the symbol Vd, and it is in the order of 10 power minus 4 meter per second. And hence current is said to be flowing through the conductor from positive end to negative end. Here is the direction of electric field and the current, both are in the same direction. Okay, draw these two diagrams. This is conductor, means metal conductor. In general, we use metal conductor, metals. So here the total charge flowing through any cross-section area in unit time is defined as average current. Note on first point. Average current, I average is equal to current flows in unit time, delta I by delta. Or simply we can write charge flows, delta Q.
Q.
In general, this can be written as Q by T also. This is the expression for average current. Within the limit delta T tends to 0, this average current is defined as, that means current at any instant of time is defined as instantaneous current. Instantaneous current or simply current, both are same. I is defined as limit delta T tends to 0, delta Q by delta. This can be written as dQ by dt. That means the time rate of flow of charge passing through conductor. Time rate, that means the derivative of charge Q with respect to time. Therefore, time rate of flow of charge, time rate of flow of charge passing through a conductor is called current, or simply electric current also. Electric current. Okay, ma. So the got these diagrams.
Yes, sir.
Yes, sir.
The next point. Here from this equation we can write I is equal to dq by dt. This implies dq is equal to I dt. Therefore, total charge flows through the conductor from time t1 to t2 is given by, how can you get the total charge? This is small charge flowing in time t2. Now what is the total charge? How can you get from this?
Integrate, sir.
Amma?
Integration, sir. Integration.
Integration, right? Correct only. Integration. Integral dq. Okay, which is equal to integral t1 to t2 I dt. Important relation. Amma. Now this one was completed. This is the lower part.
Yes, sir.
Yes.
Here by this definition, what is the SI unit of current now?
Ampere.
SI unit of current. This is the charge by time kadamma. What is the SI unit of charge?
Coulomb per second.
Right, Coulomb per second.
Ampere.
Ampere.
Coulomb by second. Correct. This is the Coulomb per second and down. Or this is also known as ampere. Ampere denoted by the symbol A, capital A. If Q is equal to 1 Coulomb and T is equal to 1 second, then I is defined as 1 ampere. That is the definition of ampere. Was it completed?
Yes, sir.
Yes, sir.
So if 1 Coulomb of charge flows through a conductor for 1 second, then the current passing through it is defined as 1 ampere. Okay. What is its dimensional formula? Here is it the fundamental physical quantity or derived physical quantity? Current. Tell me anyone. Emma.
Current.
Current, electric current, is it the fundamental quantity or derived quantity? First year last year the main and dimensions
Fundamental.
law. Ma, tell me.
Fundamental, sir.
Fundamental quantity only, correct only. It is the fundamental physical quantity. It is not a derived physical quantity. Here along length, mass, time, electric current, temperature, thermodynamic temperature, and quantity of matter, luminous intensity. These four are also considered as
fundamental quantities.
Fundamental quantities. So current is one of the fundamental physical quantities. So its dimensional formula is A itself, Ri. So here dimensional formula of current is A with the square brackets, or we can represent this as I also. In some books A, in some books I may be used like this. Like M for mass, L for length, T for time. It also has only one letter as a dimensional formula. Next point. Current has direction. That is flows from high potential to low potential. But it does not obey the laws of vector addition. Laws of vector addition. So current is a
Scalar quantity.
scalar quantity, right? Current is a scalar quantity. Here this is one current I1. This is current I2. This is theta. This is I is equal to simple addition. I1 plus I. Excuse me. Okay, ma?
Yes, sir.
Yes, sir. Yes, sir.
Okay. Note points, ma. Note 1. If n number of charged particles, each of charge q plus q flows in time t, then what is the current now? Equivalent current. Then current I is equal to
And
total charge by total time taken, which is equal to nq by t. Next, note 2. Here this is the discharge tube, let us consider. This is the discharge tube. Here, positive, negative, and so on are connected like this. Discharge. 2. If hydrogen gas is taken H2 gas, then here this is positive terminal. This is positive, this is negative. No. So here protons are moving. H11 are moving. Ionization takes place, and H11 moving in this direction. Electrons are moving in this direction like this. Electrons. Protons are moving H11 and so on like that. If N1 number of protons and N1 number of electrons are flowing, then what is the current in this center? Current I is equal to how much? This is current I. If N1 number of protons H11 and N2 number of electrons flows in time t, then current, here this is average current in general. Average, here also average amount in general is equal to N1e plus N2e. Here is a plus sum, even though it is an electron, that is equivalent to charge, flow of positive charge only, divided by T. So this implies I average can be calculated as N1 plus N2 into E divided by T. Only electrons flows, so we consider only Ne like this. That is note 2. Next, another important note 3M. Here, this is the center of a circular path. This is center O. Here, this is a charged particle Q plus Q, let us say. It is revolving, whose radius is equal to R, with velocity V, rotating in anti-clockwise direction with an angular velocity omega, let us say, about this center. Now, what is the current equivalent to the circular path of the charge and data? That also important formula. Is it completed this one?
Yes,
Note
sir.
2.
Yes, sir.
The average current associated, the average current associated with the revolving charge plus Q, as shown, plus or minus, no problem, whatever it may be, as shown. Is given by I average is equal to charge Q divided by time taken to complete one rotation, time period, which is equal to Q by time taken to complete one rotation is with velocity V. For one rotation, what is the distance traveled? Emma, for one rotation, what is the distance traveled?
2 by
2
R.
by R. With velocity V. So with velocity V is the time taken to complete one rotation. So this can be written as QV by 2 pi r, where V is linear velocity of the charged particle. Okay, but V, what is the V? V is equal, what is the relation between V and omega? V and omega. First is the rotational motion. Relation between V, omega, r,
Omega by Q.
V is equal to r omega.
Yes, sir.
V is equal to r omega. That's why we can write Q into omega r by 2 pi r. So r cancels. Therefore, I average is equal to Q by T. But here reciprocal of time period is known as frequency of F, which is equal to QV by 2 pi r, which is equal to Q omega by 2 pi. These are the different formulae. Based on the given data in the problem, we can use this or this or this or this. If time period is given, we use this. Frequency is given, we use this. Velocity and radius is given, we use this. The angular velocity given, we use this. Simple. Where? What is capital T, Amma?
2 pi r by V.
Capital T is time period. Time taken to complete one rotation is known as time period. What is F? Frequency, which is equal to 1 by T, the reciprocal of time period. Number of rotations per second. This is also known as number of rotations per second, or reciprocal of time period, known as frequency. What is V?
Linear velocity.
Linear velocity. R into radius, no problem. What is Q? What is the omega? Not Q.
Angular frequency.
Angular frequency.
Angular velocity, right? Angular velocity. Instead of charge Q, if electron is given in nth orbit, if electron is revolving in nth orbit around a nucleus, then what is the current associated with the revolving electron antadamma? Same formula. Instead of Q, we write E. That's all. Okay. Note down the note 4. The average current associated with the revolving electron in an orbit of an atom is given by I average is equal to same formula. Instead of Q, we write E only. E by T Q F, which is equal to Q into V N, where N is nth orbit, by 2 pi R N. This is the velocity of electron in nth orbit. This is the radius of nth orbit, which is equal to Q into angular velocity of electron in nth orbit by 2 pi. Here velocity of electron in nth orbit is directly proportional to, radius is directly proportional to Z by n square. Is it correct or not? Bohr's model, Amma. One should use those formula also here to calculate the comparison on matter. Oh, instead of Q, we write E. E Vn by 2 pi Rn. E omega n by 2 pi. Vn is velocity of electron in nth orbit. Rn is radius of nth orbit. Omega n is angular velocity of electron in nth orbit. Here in this case, there is no such orbit somehow. Only charge is rotating about a point. But in this case, electrons means here its velocity, radius, and the angular velocity are different. Excuse me. Am I clear or any doubt here in this? Students,
No doubt, sir.
this is about different forms of calculation of current in objective point of view. Next, current density. Here, current pass through any conductor is same to any cross section. That means if any conductor has a irregular area of cross section like this, if current I enters from this conductor, the same current should leave the conductor. Okay, even though this area of cross section is less, same current should flow. That's why there is a necessity of defining another physical quantity, that is current density. That is the current passing per unit cross section area. Here cross section is more, but current is the same. Here cross section is less, but same current coming out. That's why here area is less, so current density is said to be more. Here more current is passing per unit area. Here less current is passing per unit area. Is it clear?
Yes, sir.
So here, if we consider the same area, then current density is also same, but here area is more. That's why this current I, same current I spreads through all the area when it enters. When it comes to this end, this total current comes out through this area only. Why? Because this is the possible area available. That's why this total current comes out through this, like pipe, water pipe. If a pipe is like this bigger one and it is attached to smaller pipe, then the same water enter into this pipe should leave this pipe. Compulsory. There is no other way. Like that, here also current enters throughout this cross section. The same current comes out to this small area of cross section itself. That's why there is a need of defining current passing per unit area. Why? Because here unit area is more, here area is less, but same current is coming out. That's why we may define another physical quantity, that is current density. It is denoted by the symbol Jm. It is a vector quantity. It has a direction. Okay, why? Because it is always normal to the area of cross section. It obeys the laws of vector addition. So it is a vector, even though current is a scalar. That is important. So note down side heading current density. This is denoted by J bar. Okay, diagrams and the definition will give the next class tomorrow. And some definitions are there in this week syllabus. Almost all we may close this week syllabus tomorrow. Okay, ma?
Yes, sir.
Yes,
Okay.
sir.
Okay, ma.
Thank you, sir.
Bye.
Thank you, sir. Bye, sir.
sir.